Okay, I'm sorry if this video is a bit jiggly. I'm just holding my phone. Right, so we know that we have got the molecular formula C6H10O. We know that it's a ketone. We know that it's cyclic. We know that there are 4 peaks in the carbon-13. So that's our parameters. Now, if I know I've got a 6-carbon cyclic structure, the first thing I always do is start with a 6-carbon ring. If I cannot get the correct structure from a 6-carbon ring, that is the point that I would then start drawing a 5-carbon ring or a 4-carbon ring or even a 3-carbon ring and popping in methyl groups. But my go-to structure is always going to be 6-carbon ring. So I know that I've got an oxygen and I know that it's a ketone. So I'm going to pop a carbonyl group there. And then I've got 10 carbons, which means I know that it's not a saturated. Sorry, I know that it's not unsaturated. I know that it's not an alkene. There's no carbon-carbon double bonds. They're all single. I'm going to pop those hydrogens in, and that gives me 2, 4, 6, 8, 10. So yes, that works. It's got that formula. It's definitely a ketone and it's definitely cyclic. Now let's check the peaks. Okay, this carbon is obviously chemically distinct to every other carbon in this structure, so that's going to give us 1 peak. Then we've got these 2 carbons here. This is a symmetrical structure, so the carbons opposite each other kind of horizontally, they're going to be equivalent, okay? They're going to be in the same chemical environment. The question is, are they in a different chemical environment to all of the other carbons? And the answer to that is yes, because these carbons are bonded to this side to a carbonyl group and to this side to a CH2 group, and no other carbons are like that. So that gives us our second chemical environment. Now let's look at these 2 carbons. So they are clearly distinct from the carbonyl carbon. They're distinct from these carbons, which were bonded to a carbonyl carbon. So that's going to give us a third chemical environment. And then finally, this last carbon, so it is bonded to a CH2 group here and a CH2 group here. Now arguably that's the same as these ones, which are bonded to a CH2 group here and a CH2 group here, but it is not the same, because if you continue around the ring then it gets different quickly. So this is bonded to a CH2, which is bonded to a CO. This is bonded to a CH2, which is bonded to a CH2, which is bonded to a CO. So it is not the same. It is chemically distinct, and it's going to give us our 4th peak. So therefore, that structure meets the final criteria of 4 peaks in the carbon-13 NMR. I hope that helps.